and the anion. The cation here is a potassium ion that comes from group 1A, and the anion is oxygen. Step 2 is to name the cation by the element name, which is potassium. Step 3 is to name the anion first by the first syllable of the element, followed by I. Step 4 is to write the name of the cation first and the anion second. Therefore, K2O equals potassium oxide.
Hello, my name is Cecilia Cobia, and today we're going to be talking about 6.4 polyatomic ions. Polyatomic ions are a group of atoms with an overall charge, often consist of a nonmetal. Example, phosphorus, sulfur, carbon, nitrogen, and oxygen. Usually they have a -1 charge, a -2 charge, and a -3 charge. And they also have a negative except for NH4, which is ammonium, and has a positive charge. All right, these are some steps that will help you out when you're dealing with naming polyatomic. One, names the most common polyatomic end in 8. Sulfate, phosphate, and nitrate. 2, when a related ion has one fewer oxygen, its name ends in ITE, ite. Example, sulfite, phosphite, and nitrite. 3, exceptions are cyanide and hydroxide. 4, when you add a hydrogen plus to the polyatomic ion, add a +1 charge. Example, carbonate plus H hydrogen plus, it becomes bicarbonate or hydrogen carbonate. An example, B, sulfate plus hydrogen equals bisulfate or hydrogen sulfate. Form 4 polyatomic ions with oxygen each with a negative charge. Example, perchlorate and chlorite. When writing formulas for ionic compounds that have polyatomic ions, you use the same rules of charge balance as those for simple ionic compounds. When naming ionic compounds containing polyatomic ions, write the positive ion, which usually is a metal, 2, and then write the polyatomic ion second. These 2 steps will help you to making sure that you're naming your formula or you're naming it correctly.
Yeah.
All right, example, we're doing NiCO3. We're going to identify the cation and the anion, which are all right, then step 2, we're going to name the cation, and that is nickel. Nickel 2. Then you're going to name the anion, which is carbonate. And you're going to name the compound, which is nickel carbonate. Thank you. This concludes 6.4 polyatomic ions.
My name is Carty Brown, and my section was 6.5 molecular compounds of sharing electrons. First thing I'm going to talk about is covalent bonds. Covalent bonds is formed when 2 or more nonmetals share electrons. Valence electrons are shared between 2 nonmetals to achieve stability. The next thing I want to talk about is the formation of hydrogen molecules. Now, as the energy increases, the distance between the nuclei and decreases. As right here, they're far apart and there's no attraction. As it goes further, the plus and the minus, the positive, the anion, and the cation attract each other, and then they form H2O, H2 molecule. Electron dot formulas. It's when there's 2 sets of nonmetals, and they have a free electron to share. This one is a shared pair after they come together and they form a covalent bond, which is F2. And then there are 7 diatomic molecules. H2, which is hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Now I want to talk about triple bonds. I use nitrogen as an example. 2 nitrogens or elements of their character come together and they form triple bonds. These two are known as octets. And last I want to say is the names and formulas of molecular compounds. Step 1, you name the nonmetal by its element name. Step 2, you name the second nonmetal, adding the "ide" at the end of it. And the step 3 is adding the prefix to indicate the number of atoms. The example would be NCl3, nitrogen trichloride. And that concludes my section.
My name is Sequisha Thompson. Today I'll be talking about section 6.6 and 6.7. Start with 6.6. Electronegativity and bond polarity. Electronegativity decreases from top to bottom on the periodic table, and it increases from left to right on the periodic table. It's higher in nonmetals and lower in metals. Non-polar covalent bonds means that electrons are shared equally, and in polar covalent bonds, electrons are not shared equally. And this occurs between nonmetals. Ionic bonds occur between metals and nonmetals. One metal and a non-metal atom. Electronegativity difference determines the type of bond. For example, electronegativity difference between 0 and 0.4 is non-polar covalent bonds. 0.5 through 1.8 is polar covalent bonds, and greater than 1.8 is ionic bonds. And that's the end for 6.7. Bond shapes with 2 electron groups are linear, which is 180 degrees. Section 6.7 covers the shapes and polarity of molecules. Then we'll be talking about bond shapes. The first, which has 2 electron groups, is linear, and that is 180 degrees. Bond shapes with 3 electron groups are triagonal planar and bent. Both of these have 120 degree bond angles. 4 electron groups are tetrahedral and triagonal pyramidal. These bond shapes have 109 degree bond angles. In non-polar molecules, dipoles and polar bonds cancel each other. And polar molecules, in non-polar molecules, dipoles and polar bonds cancel each other. In polar molecules, one end of the molecule is negatively charged than the other.